category, which will be the lighting design. And we want to learn, this is our target at the, after spending 45 minutes with us, you will be able to create this kind of a fixture, which is parametrically controlled uh, on your own. Feel free to ask your questions in the chat. If there is any doubt, anything, be it small, something is not understandable, the logic is not clear, so feel free to ask anything there. Any of us will, like we are a big team here assisting you, so we'll be able to answer you instantaneously there. And if you are completely new to BeeGraphy, as I told you that this is a workshop series, we are on workshop number 2 now. There is already the videos of our workshop 1 in the uni.xyz platform, where you can learn the basics of BeeGraphy. So I highly encourage you to visit that as well. If for certain reason you were not able to join in our workshop number 1. So if you go to the competition and learning resources, there are a lot of tutorials by Jose, by Katie Minas, and our first workshop about the basics of parametric design and introduction to BeeGraphy. So highly recommended to check this out. Perfect. So this is our intention for the first 45 minutes. And let's get right into it. A simple interface. I saw that some of you do not have a BeeGraphy account. So please get your account, please create your account, then log in. Once you log in, the login sign up is completely free. There is no restriction on what you can use, what you cannot use. All the tools, all the advanced things are at the moment completely available for everyone in the free version as well. So as Learning already introduced, there is an editor and a marketplace. So our first interaction will be with the editor, in which it's like a blank canvas where we are trying to create the form that we intend to get out. As soon as you go to the editor, there is this page you come across. All of your data is, rather than being stored locally in your drive, is already on cloud. All your forms which you have explored in BeeGraphy are already available here. So we are going to create this form from the very beginning. So let's jump into creating a new model. So this new model will open up like a blank canvas, like a new Grasshopper file or any new 3D modeling file. You can give a name to your model. For me, I can say it's lighting fixture. There is no restriction of the name. You can do whatever, you can put whatever you want to call it. As soon as it's created, we see something like this. You are already familiar with the BeeGraphy interface, but let me spend like a couple of minutes to refresh your knowledge and to, yeah. So this is where we see the actual form. There are these settings where you can control what you want to see, whether you want to see the grid or not, and what is the quality. So a low quality will be faster to process, a higher quality will take some time. Then there are different view modes, whichever you want to see. So this small window, which will always be there, is similar to what you see on the Rhino thing. If it is for those people who are only familiar with Rhino till now. So your geometry will be real time visible here. And this becomes like your Grasshopper canvas where you can drag and drop any components. Again, you can just double click and type in whatever the component you would like to take. For example, if I want to take create a circle, there are multiple kinds of circle. I want to create a circle with a center and a radius. So I just create this one. And then you see that immediately this is visible in your graphical user interface. And interesting thing, as soon as I select something, the color changes to yellow. So you can easily identify which element is resulting to what geometry. The way where it gets even better than Grasshopper and Rhino interface is that it is reverse compatible as well. In Rhino, it is just one-way compatible, that if I click on Grasshopper, I can identify the geometry inside the Rhino. But if I know the geometry, I cannot find the element, which is not the case here. So here we can select the geometry as well, and the component will be visible. I am not sure why it is not happening right now. Let me just reload it. Yeah. So selecting the geometry will lead to highlighting of the component as well. Perfect. So this, and here are all the different components, some core components, the materiality, exporter, list, tools. If you cannot see some of them, there might be like a small drop-down menu. And from there, you can select it to get activated, and it will be just pinned. So a lot of tools already inbuilt, from panelization to arrays to lofting to image processing and so on. And we are just going to use all these native components to create our form for today. Great. Then let me start with a whiteboard. This is our target geometry that we want to achieve. And then let's see how we can parametrically break it. What could be the way we can achieve this kind of a form? So what happens? When I see the geometry, what I realize that it is predominantly an extruded cylinder, but there is this tilt in the center. If I look from the front side, I realize that this bulge, this is not parallel to the horizontal plane. Like if there is a circle here, if there is a circle here, this circle is not straight. It is not parallel. It is like somewhat tilted. So if I just try to draw it, what it may look like. Let's say this is our circle on the top. This is our circle on the bottom. So rather than being parallel to our uh, two circles, the top and bottom, this seems to be tilted in this fashion, the one which you can see in the red line. Exactly. So this is somehow we want, this is this is like the first apparent thing which I can see. Again, one thing related to parametric design in general, I would like to share that there is no right or wrong method in parametric or computational design. There are hundreds of ways that the same result can be achieved. In the time constraint that we have today, uh, I will be following a one or a two approach to reach this particular end result. But it doesn't matter that it doesn't mean that all the other ways of reaching to the same form are wrong. There is no right or wrong. There is just more efficient and less efficient ways. So there could be some ways which are, let's say, less taxing on the computational power, which are easier to achieve, which uses less components. So we always thrive to follow that processes in which our input, our investment of time, our computational resources is the least, and it results in the same outcome. But for in the beginning stages, even if the process is not super streamlined, not super optimized, it is okay to follow that process. That slowly, we will start to get that intuition that, okay, this can be done in this way as well, which could have given the same result, but in a faster way. So one thing we are clear now that there is this one circle we want on the top, which is horizontal. There is one circle we want on the bottom, which is again horizontal. And then there is the tilted circle in the middle. And then if we are able to somehow connect them smoothly, all of them, we get closer to what this form is trying to achieve. But certainly not in a two-dimension. It is all happening in a three-dimensional in circles and cylinders. So let's be easy. Let's start slowly and put these three circles in and then see what happens. So let's start with the bottommost circle, which is this, and you can choose whatever the size. So it's mainly based more on proportions rather than trying to identify the actual size at the moment because we are in the exploration phase. So let's say I am having the bottom radius, which is this red circle, as 3 here. Perfect. The good part again about BeeGraphy is that I do not need a separate component or an element for all the input. In Grasshopper, it's not very easy to embed the inputs. It's more preferred to add them through a panel or through a number slider. But here, I can just click on the numbers after this to change them. So if I want a radius 3 instead of 4, it is much quicker. If I do something in this fashion in which I create like a number constant and I write the number as 3 here, and then I connect it to this one, perfectly all right. It gives us the same result. The circle is exactly the same. It is just that if I write the number directly here, we are a bit faster. But if you want it to be a parametric component, then we can definitely add like a range or a number slider if we want it to be varied. But let's start with a simple approach where we can directly add the number here. And also with the point, I'm not required to create a center point for the circle. I can just write the coordinates x, y, and z in the in the in the options here. So x, y, and z coordinate. I'm already creating I'm right now creating this bottom circle. So it has to be on the 0, 0, 0 axis. So no change required here. Great. So I have the bottom one. Now let's create the top one. And let's assume the height of everything will be like 7 times high than this one. So if the radius is 3, then we can do a 21 thing. I can copy and paste by simple Control C, Control V, any element, or I can take a new element again by following the process of double clicking on the canvas and then typing what I am trying to get. The other way to input is to go through the panels on the top if you do not remember the name of any particular component. Let's say this is a circle, it is in the tools. We are talking about primitive curves, basic curves, and I can see the circle here. All of this will result in exactly the same thing. Just you have many options on, and it's based on like what you find suitable, how your workflow is. So bottom and top circle, the radius, the size is exactly the same as I see in this geometry as well. It is just that it is rather than being located on the ground level, it is on a higher plane. And how can I define a higher plane? I can simply, the radius is already 3, I can simply change the z point to a positive higher number. And if I do that, I see that, okay, this circle is now placed here. If I just like play around with a bit, if I put 10 here, then it will be at the positive 10. And if I do 20, it will be at a higher level and so on. Let us go with 21 at the moment. So I need 3 circles. I have the top one and the bottom one. And let's get now the tricky one, which is the center. We already know that the center circle will be slightly bigger. So to have a slightly bigger circle, what I should do, the simplest method is to just increase the radius of the circle. Let's try to do that. I'm copying the circle, which is at the very bottom. And then you can see that when I click this, the yellow thing appears here, which means the circle is located here. We already agreed that we need a larger circle, so its radius should be higher. So let me increase the radius to 5 from 3 to make it a bit bigger. And I can see that there is a larger circle now. But what we see that the circle is not here. It's somewhere in between the top and the bottom circle. It's at 0 z point. This is at 21 z point. So let's take 10 or 11 to get the middle point. And to change the location of the circle, what I have to do, simply just in the origin, change the value here. So remember, if you wanted to change the location of your circle, change the origin point. If you wanted to change the size of your circle, change the radius. We used both of them now. Cool. I see three circles aligned vertically, stacked vertically one on top of one another, and the center one being a slightly bigger circle than the other two. So what condition I am now? I'm in this blue condition now, that where I have two circles on the top and bottom of the same size, and then there is another third circle in the center, slightly bigger. But we already established that we do not want to have the center circle to be parallel to the top and bottom one, but rather it should be like slightly tilted. And to get this kind of an effect, not like a just a small, just like a a clear bulging effect. For example, we do not want a situation which is like this, in which it is just bulging equally on the sides, but we want something like this. So how to rotate the center circle? Simple. If we want to rotate, it is intuitive. Let's take the rotate command. And our target will be now to just provide all the input for the rotation. The geometry we want to rotate, it's certainly the center circle. So let's add the geometry to the geometry. Angle. This is one thing to remember, that the input for all the components, wherever an angle is required in BeeGraphy, is by default in radians. I am personally, if you are familiar with radians, you can directly change the values here. But I am particularly more familiar with the degree convention. So there is already a command which says degree to radian, DEG to RAD. So I can just use this command and then add here. And then I can just choose the value here. Just as a placeholder, let me put 45 degrees for now. Okay, now I have to put center. At what point I would like to rotate this? What is the axis of rotation? If we go back to our small ugly design, we can see that we want to rotate our central circle. And this means that what we want to rotate is along this point, the yellow point, which is, let's say, the centroid or the center point of this blue circle here. And but I do not know what is the centroid of this blue circle. I just have a circle right now. So to get a centroid, again, very intuitive, very simple. I need a centroid, so I just type centroid, get the centroid option. I put the circle into it, and then I get the centroid, which is this yellow point, which is exactly the same yellow point which we are expecting to rotate our design at. And then I create the center point to the center here. And now I finally have to provide which axis we want to rotate it to. And this we can do clearly by providing a vector here, whether it's the x-axis, y-axis, or the z-axis. So you see, it is like right now rotating along the z-axis. Rotation along z-axis, what does it mean? Let me just show you here. Now this is the top view. If you look from the top, this is our circle already. This is our yellow point, which is the center. Rotation along z-axis means it is getting rotated. So my circle is getting rotated, but I do not see any change here because it is along the z-axis. So where we need to rotate it along the x-axis or the y-axis to see it visually similar to what we are trying to achieve. So let's try rotating it along the y-axis. And to do that, again, simple. I need not to create any vector. The vector is already here. So I can simply put z-axis to 0, and I can add 1 to the y-axis. Now you see that this yellow circle is the rotated form. I already have a circle which is rotated along the y-axis. Let's quickly check what will happen if it is rotated along the x-axis. It will be along the x-axis now. So very simple. You can play around. You can have a mixture of x and y, whatever you feel comfortable in. So let me just go back to y. I like it in this way. And I already have the circle. So it was pretty quick to achieve this form in which I have the top right circle, the rotated circle bigger here, and the bottom circle. If I just switch off the visualization of this here, like simply clicking on the three dots and then selecting hide, the component still exists. I am just not seeing it. So if I hide this point as well, I now get a form which is pretty similar to what I intended to achieve in the first place. Great. Our first step is fully done. Now, what was our next step? Our next step was to create like a smooth boundary around them. You see the new yellow thing which I'm adding, that we now somehow have to connect them as a surface rather than being individual circles. The immediate thing to do is to use a command known as loft surface. And now we simply have to add 1, 2, 3 curves in it and then see what happens. It is important that the order of the curve that goes inside the loft is maintained. So either go from top to down or bottom to top, but in the correct order. So it's like a more clean way to do it is to use this component known as merge. So merge combines all the data streams, the data coming from these three curves, and then it will be lofted together. So I'm going from, this is my bottom one, so I'm going from bottom to top. So I add the first curve here, the second curve, which is the middle one, by pressing the shift key, and then finally the third curve here. And then if I add it to the loft command, I see something happens. But I realize it is not what I intended to achieve. It is not looking like this. Because what is happening right now, if I just draw a quick sketch again, I have one circle here, I have second circle here, and I have third circle here. If you just see this geometry, this is what our situation is. And now lofting the three of them, it is combining the extreme ends of the three together in something like this. This bulging thing, which is shown in the blue dashed line, is not happening. So how we can achieve this bulging thing? If we can add one more circle here and another circle here, then what will happen is it will try to achieve, now follow my pink line, it will now try to follow the outer points of all of these 5 circles instead of just the 3 circles. So hopefully, if we do this by adding these two circles here, the one which is this, the other which is this, we are able to get closer to the form here. So let's try that if it happens or not. One thing is, uh, let's give it a slight thought whether we want to add a circle or an ellipse here. You might be wondering why the ellipse is coming into picture. If you just see that this circle is actually like a tilted circle or like a rotated circle. So what happens if, let's say this is my circle, if I rotate it, it will be rotated like this. So its width is getting reduced. The pink line, you see that I'm getting like a gap here after rotation. If I just show it on the top view, what I mean by this is it's if, and this is the top view now. If this is the circle, I'm now drawing the rotated circle with the red. This will be the rotated circle. But I do not want this. I want like a the red will be the rotated circle. But I do not want this. We want that the circle to be precisely a cylinder in the top part and the bottom part. So how we can solve it? How about if I use an ellipse instead of a circle? So let's say in the plan view before rotation, it looks something like this, the red you see. So what will happen? After rotation, it will give me like a perfect circle here. Going to this drawing again on the left, we wanted to have the cylinder. This is the circle on the top. If I have an ellipse here, which is slightly bigger in this side, after rotation, I will get an ellipse which is having the same dimension as my circle on the top. So this is because of we are rotating it. It is better to go with an ellipse, and then we can get like a perfect cylinder. You can try it with circle as well, give it like a hit and trial, and then see whether you like that feel, that appeal of the circle. Otherwise, go with an ellipse. And for if I want an ellipse, what I will do, I just have to type an ellipse. Okay. Right now, I cannot see where my ellipse is coming because I have this lofted surface here. So to hide it, we can quickly go to the lofted surface and press hide. And then the things become much more cleaner again. Okay, my ellipse is here. I want it to be somewhere here, ellipse. I know that this was my uh, center point, which is 10. I used it for this circle. So I have to go higher than this. So I can just put the origin is the z-axis 13, 14. I can't decide, so let me put 13 and a half. Now I see the circle is too big. What I want, that in this direction, the width remains the same as 3. And in this direction, the width is a bit higher, so that after rotation, in the plan view, it start looking like a circle again. So what I can do, I can change the radius. I change the radius to 3, which is the same radius as the radius on the top. And is this direction slightly higher? So let me go with 3.5. Perfect. So now I have an ellipse here, but it is not rotated yet. I need to rotate it exactly the same way as the circle in the center. We have to follow the same approach that I followed here for the center circle. We use the component known as rotate. Simple. Rotate geometry goes to geometry. To rotate around a certain axis, I need the center. Again, centroid, curve geometry, centroid, and the point goes there. I have the center here now. I do not want to see this point, so I just hide it. And how much I want to rotate it, it's exactly the same as this one. So I can directly connect the same input, which I create, the radian input, which I created for the center circle, to attach here as well. I see it doesn't seems to be rotating around. It's again the same thing that we need to decide the axis where it is rotating. By default, it is along the z-axis. I put the z to 0. We want it along the y because we did the same in the center one. And I put the 1 to y. It looks a bit messy. If I just hide it, I can see clearly that, okay, now it is more or less the same size and it is getting sliced properly. But I think that this angle is very strong right now. I need like a slightly lesser rotation. So I can change the angle here to 30 degrees and then let's see what happens. But visually, it looks pretty fine to me at the moment. But this is all not done. It is just we got the cylinder in the top half right now. We need a cylinder like a continuous flow in the bottom half as well. So what we do, I can copy the ellipse. Yes, I can just see it. It is exactly the same ellipse, but I do not want it so high. I want it now lower than our central circle. The center circle, you remember, was at Z location 10. So to get it a bit down, I can, the Z location is 7, a bit lower than this. And mind that it is like parametric design. So these numbers are uh, can be changed easily. You do not have to start the form again. That is the biggest perk, that is the biggest benefit we get out of parametric design. Just we have to simply change the number and we get like a new form out of it. Cool. And again, I have the now circle parallel to the to my bottom circle, but we do not want it to be this way. We want it to be parallel to our middle circle to create a cylinder here. Follow the same methodology. I'm copying the rotate component here. The geometry is the geometry, which is our new ellipse. The centroid I need to find out for this new circle. So I add the component centroid, pass the curve through it, and then put the centroid in the center. The angle remains the same. So all three of them are getting rotated by the same thing. Let me hide it. I do not want to see the centroid as well. And now we have like 5 circles here. Exactly the 5 red lines that we wanted to have. And the good part is, if I change the angle here, all the 3 angles get changed together, which is pretty helpful for me. Okay, now let's add all of these 5 things to the loft and then see what happens, whether I'm able to achieve the geometry I imagine or no. If you remember, few minutes ago, I told that it is imperative to go uh, sequentially in assigning the surfaces, assigning the curves. So you can either go top to bottom or bottom to top, but they have to be in series. I cannot insert this circle in between the already installed and already merged list. So I start in providing all the data right from the beginning. Again going from bottom to top. So this is my extreme bottom ellipse. This is my ellipse right on top of it. So keep pressing the shift key and add it to the list. This is my ellipse. This is my circle, central circle, the biggest one. Keep pressing shift, add it. Now I want this ellipse, which is this one precisely. Yes. And now the top circle, which is not this, but the one at the bottom in my case. And this. So it doesn't matter where the stuff is located on your canvas, just the order of providing the input to the merge list needs to be taken care properly. I see the list. Yes, there are 5 input there. And now I switch on the visualization of the loft surface. If I zoom in, yes, it looks pretty cool. This is the kind of stuff I imagined to achieve. Yes, very similar. To get it more clear, I am just hiding all the circles so I can concentrate in visualizing the surface that is created out of these 5 basic circles. So you can like multi-select different components and then just hide them. So everything will be hidden together. If I change the angles, let's say from 30 to 35, okay, perfect. Changed a bit, everything, and it looks good. Let's say if I want it to be a bit taller, I can just change my top circle height a bit. So right now it is at 21. Let me make it 24. It's higher. Great. I like it even better now. So let us go ahead with this. So it's just that, again, I'm repeating myself, but it is very important to understand parametric design. It's about parameters, and you are allowed to change parameters anytime during the workflow. So it's not like a very creating of an algorithm is a linear process, but modifying the geometry, modifying the form out of it is based on how you want to achieve it. So I like this one better now. So I just go ahead with it. And it is not yet that I have finalized this one. I'm just writing a script right now. And after 10 minutes, I maybe come back to this and then uh, change some parameters again. But I do not have to write the script again. I'm just changing few parameters and I'm getting a new form out of it. Perfect. So this was the most tricky and let's say parametrically intensive part to identify what exactly we are doing. And it's very interesting to see that just with like basic uh, primary geometry like circle, we are able to get this parametric form. Perfect. Now I want to create like these kind of a finned structure to it, which has a width to it. I do not want like a surface. I want these individual panels rotating around. For this, I need like a thickness, how thick I want these panels to be. If I want to add thickness, what command we can use? Side thickness. No points for guessing this one because now, as you know, BeeGraphy, very intuitive. Whatever you want to achieve, just try to type it out and there is a very high probability that you will get a component which does exactly the same thing. So what kind of input needs to be provided? It just needs a surface and a thickness, how thick I want it to be. So it converts surface into like a solid of a particular thickness. Right now, the solid thickness is 2. The surface is surface input. Let me just provide the surface and then see what happens. I hide this one. It is extremely thick. I have no space in my geometry. So I want it to be thinner, but I want that the mass, the thickness which is being added, it should not be added inside the geometrical surface, but rather outside. What we can do, it's simple. Rather than having a plus dimension, let's add a minus in front of it. So rather than +2, if I do a -2, what happens? Now the whole thickness addition goes to outside, but it is super thick for my taste right now. It just doesn't look like aesthetically pleasing to me. Let me reduce the thickness here. Much better, but I would like it to be even slightly thinner. Let me go with, let's say, 0.75 minus 0.75. Perfect. I like this much. So you see, in just like 20, 30 minutes, we are able to get this solid geometry, which looks pretty cool and similar. But uh, at the end of the day, what we are creating is a light fixture. This is a solid. There is no gaps for the light to come out from this one. So I need like openings here and just like thin slits rotating around. And how we can do that? For that, we will use, there are thousands of ways to do it, thousands of permutations and combination, but we probably are going to go with something related to, let's say, solid interaction, solid intersection, and then create these individual slits. So how does a solid intersection works? Let us see on this canvas itself. If I have a solid cuboid, And then I have another solid cuboid with some part where they are overlapping. The place where they are overlapping will be the result of the solid interaction. So intersection. So what is happening? That I provide two solid as an input, and then we intersect them, and whatever is the common solid between these two will be given as the output. I already have one solid, and now you can see properly in the action what I meant by reverse compatibility. That, for example, there is a canvas and there are a lot of geometries going. I want to see which component was leading to that geometry. I can simply select this in my visualization, 3D visualization window. And as soon as I click on it, I get the, the component highlighted, which is leading to this. So then it gets like a complicated large script, very helpful to get oriented and sort things out. Great. I have my first geometry, first solid here. So what we want to do, we said that we want to do a solid intersection to do that, where I can find the solid intersection. In tools, there is already a lot of Boolean operations, and then there is this thing known as a solid intersection. Perfect. Otherwise, I would have just written solid intersection, and I would have gotten the same thing as well. So for solid intersection, I have my first solid, correct, but I do not have these fins. So I need to create these fins. How about we create like a plain rectangular slits around, like rotated around the geometry, and then we use them. Let me show you what I mean by them. Let's create like a plywood panel with some thickness, like a solid cuboid, like a box. So let's create like a box kind of a thing. Yeah, box. But this is not the ideal box. There are other ways to create a box. Yes, I can create a box by 2 points. Perfect. So I need a box which is at least the height and which is intersecting. So what I mean, let me show you again. That let's say I already have this solid geometry. It doesn't look like what we have, but just imagine that it's the same thing, the red geometry. What I want to do, I want to create like a cuboidal box here. And when we intersect them, then what will be the result? It will be the result like one panel of lighting for me. So like a one singular panel. And then I can just like copy the singular split in rotate them around, copy them in a circular fashion, and then I think hopefully I will be able to achieve it. So let's give it a try. So if I see here, I need the box which is completely covering from the center part till the extreme uh, corner in height and in the width of my lofted solid, which is the one in violet color. So let's just change the points. I do not want it to start very center. So I just type, let's say 0.2. So we just get away from center a bit. And the width could be about the thickness, how thick I want the stuff to be. And I have to make it a bit down. So let's do this. And here as well, width of 10. Yeah, this covers everything. So 10 is okay. And here I can just increase the height. Now, yeah, it looks pretty good. So what were our parameters? This is exactly the same thing which we were trying to achieve here. But I need to create like a solid box. And this is just one way of creating a solid box. You can create like a rectangle and then extrude it. You can define multiple points. You can define a bottom surface and then extrude it vertically the way you like it. The thing to remember is that we need to make sure that all the inputs are properly done. So yeah, this looks good. I have a solid box. If I intersect them, let's see what happens. The Boolean operations are pretty computationally intensive, so it takes some time. Let me hide them, and then let's see what happens. It is the reverse thing that happened. I actually wanted this slight thing to remain, but it created the other one. So what we will do, we will just like shift we can change the solid 1 and solid 2. To remind you that solid functionalities are pretty computationally intensive. So uh, use them wisely. Do not change them. Okay, something is uh, not going as expected. Then, okay, let's keep on creating our stuff. And then let's see what happens in the very end. In the meantime, I can just disable this component so that it doesn't take our computation power. What is happening right now is there is only one panel. We want that it should be there all around. So how we can do that? There is something known as a polar array. Polar array just means that I have one element, and a typical linear array is that I can create like a linear line out of it, as you see here. A 2D array is that the same line is happening in a two axis. And in polar array, what happens is that I define a center point, and along this, the items are rotated. And this is exactly what we want to achieve as well. That we want to have a center point, and along this, the elements to be rotated. So we want this rectangular sheet to be rotated around. Then let's do polar array. I want the box to be moved, and perfect. This is what I expected, that it is rotating all around. And we can just directly set the count here, how many boxes we want. Let's say I want to have 25 boxes. So let's say I want to have these 25 slits around. You can change how dense you want, how much light you want mm, to be, how much light you want it to be coming out. But yeah, pretty much sorted. I have a polar array working well. And then let us do solid intersection. Again, let's try if it happens this time. And this is the geometry. So I want my central solid to be intersected with all of these panels. And the resultant should be our panel creation. It's going to take a couple of minutes, like a minute or so. So I stop sharing the screen. We are towards the end of this session. As soon as this is done, we will be okay. So if you have any questions, you can open your microphone as well. Otherwise, the chat is always there. I think everything was super clear for everyone, and there are no questions.
You guys can share your question on the chat message as well. So great, Ayush. I think we have concluded the first session of this
Just give
workshop.
me a minute. I just like show you the final result, what we are able to achieve with this one. Yeah. And we will have our next session at in 10 minutes at 1:15 GMT. So just like calculate based on your local time what the thing is happening, and then we will learn to create a drone in that session. And let me
Perfect.
quickly share the screen before we go out. That this you already saw the glimpse of it, but just again quickly, that this will be the thing which we will be creating in our third session about urban form. So stay till the very end, and we will finish our day with recreating this thing.
So I will take a 10-minute break, I think.
Yes, yes.
But we
And
are here, so you
in
can
the
ask
meantime,
any question in this 10
exactly.
minutes. Yeah. So you guys, those who want to take a break, they can quickly have their 10-minute
And
snack.
think about it. Try to just play around with all the tools. There is,
Yeah.
do not follow exactly the same steps which I did. This is just a guide. The computational design is about expressing yourself in the way you find it most convenient. Just try different elements and try to achieve the same result. And if you find any troubles in between, we are open, we are there to get them sorted as well. But just play around, get your hands dirty, and just try to like be there in the interface for some time, and you will get there for sure. Perfect. So now we just have 8 minutes left, and see you there in some time.
Yeah. So Daniel wants to ask something.
Hello, good morning.
Hello.
Thank you for doing this presentation. This is my first time using BeeGraphy, and I was trying to follow along with the LAMP tutorial, and
Mhm.
you were saying that there's a lot of computational power. As you were saying that it crashed on my end,
Mhm.
and I'm trying to open it up again, and unfortunately, I'm not able to.
You
Um,
just have to reload it and just wait. So that is a good part and a bad part. The good part is like none of your local computation power is being used to do that. It is happening
right.
on the browser completely. And the second good part is that everything, whatever you do, is getting saved instantaneously. So none of your progress is being lost. So for me personally, I have come across many scenarios in Grasshopper. When I created something, I just was not able to, uh, I just did not, let's say, properly manage the list. The computation got super heavy and I lost a lot of progress. So the best part, you will not lose any of your progress. Whatever you did will always stay. You just reload it and you will find yourself in the exact same spot where you left.
Daniel, just a quick question since, as Ayush mentioned, it's the computations are done locally in your browser. Can you share the specifications, like what's the CPU RAM you have? I'm curious whether, or maybe you have a lot of tabs open. Maybe you, like, if you
Oh,
close some of the tabs, it will help you.
maybe. I'm not running this on a powerful computer at all. This is I'm running this on a pretty old Microsoft Surface. I think one of the first models. I think I think I'm lucky if maybe there's 4 gigs of RAM on this thing. So we're working with a little bit of a limitation here. Um, yeah, but so it might take me a little while before I get back up on this.
Then
Little
spend some time and let's see if after our break it gets resolved or not. If not, then maybe Larry can have a look again if everything technically is right or wrong.
Yeah.
Uh, One thing Ayush already also noted, that you can achieve the same thing very different algorithms, scripts, and for this one, Ayush, you used lofting and booleans afterwards, like both lofting and booleans,
Booleans are heavy components.
heavy
Yeah.
computationally. So Ayush, like, I'm definitely have a lot less experience than you. But why didn't you use like divide by count and then lofting? Somehow instead of you could do that, right?
No, for us, like the target is that in our overall workshop series, we have to introduce all our participants to all the components that exist there, like the whole length and breadth of BeeGraphy.
Mhm.
So it is much easier and much more prudent that we use these components when we are doing like small forms like lamp and all, rather than large forms like facade and everything. We do not want to skip any of them. Like everybody should be aware of what all are the possibilities. So maybe it's a good challenge for Daniel to try to achieve the same form, but in a much less computationally aggressive format. So just give it a try if you are able to achieve it in a different way.
Also, try to achieve it using simpler computations.
Yes, without using any solid Boolean. And then there are, I must tell you, there are at least 10 different ways. Learning already gave you a hint about what is the one possible option, but that is not the only way around. There are many other ways as well.
So this will be my challenge to think about for the rest.
This is your homework, let's say.
All right, will do.
Perfect.
So anyone else has any question?
Daniel, if I'm not mistaken, you're also on our Discord.
No, I'm not on the Discord. Oh, I'm sorry that I didn't respond to your. I think you emailed me earlier in the week, Nick. Right? I'm
Oh,
sorry.
okay, because I remembered your name.
Yeah, sorry for not responding. I just I was reading. I got really busy. But I saw that you were pointing me to some of like the entries, and I was gonna take a look at some of those today. You know, just I've been brainstorming a little bit to what I might be able to do with the software.
Okay. The reason I mentioned Discord, well, if you're not there, you may use it to ask questions. Uh, our team members would answer the questions. Like if you need advice on how to do this or that algorithm, like share the design, maybe ask some advice from our team or from the community. There are a couple of active people that are also on this call. I mean, outside of our team. Maybe I take a time, Lars, to thank you for being so active and helping the community in general.
Of course, I find that I always find like I guess new ways to express yourself. I guess creatively are always you know it's always something that's worthwhile to at least look at, or you know it's I always like challenging myself, learning new things. So you know this is a good opportunity for me, I think.
Good. Anyone else
Perfect.
having any questions? Like, well, maybe you can share some feedback in the chat box. Like, was everything clear, or like, is the pace good enough, or you want it slower or faster?
We are also launching some polls and within the workshop. So anyone who wants to take a break and wants to share their opinion, thoughts in the poll section, so they can go there, vote on the ongoing polls. Anyone has any question about the competition part? I'm happy to answer that as well.
Do you guys host all the computations like on your end? I'm wondering if like you guys worry that you know if maybe like a lot of people are doing computations at once, that it would overload the site or overload the software because you know it's being processed online and not locally.
No, it's being processed actually. The computation is done locally on your computers. So what BeeGraphy stores is the algorithm itself, and we are synchronizing. So what you're doing locally is in sync with the storage, but it's only on the algorithm side. The computation and the rendering is done on the client side. That's why it's not working on your Surface, for example. Like if it's an older device, you may have issues there. But at the same time, that allows us to make it accessible, because if we handled all of the computations on our service, we would have to have a lot of cost, and then we would probably be unable to make it free.
Learning,
so
are you? Sorry,
Sorry.
Daniel, go ahead.
Sorry, I was just gonna say like, oh, that's how you're able to like I guess save it instantaneously. I was wondering about that.
I didn't get it. What was it, a question?
No, it wasn't a question. I was just making an observation.
Okay.
Learning, I was asking whether you have any like future plans to also offer like cloud computing to some premium paid customers. They can, rather than running everything locally, it can be done on a cloud for those who do not have a strong machine.
Yeah, probably as a paid feature.
Yeah.
That's something we could add in the future to reduce the load on the local computer. We can do the computationally heavy part. As a minimum, we can do the rendering part,
Mhm.
because in most cases, rendering is what takes most of the computational power. We can do it on the server side. Apart from rendering, I think only it's a few computationally heavy operations like Boolean operations that are heavy.
Mhm. Mhm.
The rest are not that bad.
Perfect. Shall we